Today we're going to apply parallel lines to work with angles in triangles. And so we know some key facts about corresponding angles being congruent, alternate interior angles being congruent, same set interior angles being supplementary, and alternate exterior angles being supplementary when we are working in the context of parallel lines. And so we're going to use and apply that a little bit here to learn about the triangle angle sum theorem, and then again to apply that thought process to the exterior angle theorem. And so the first thing is to make sure that we know that our goal is to find the measures of interior and exterior angles of triangles today. So we're going to do a little bit of algebra, a little bit of some solving equations, and going from there. Here's a little bit of background information that I'll just expect that you know kind of moving forward. I'll try to draw your attention to this every once in a while over the next couple months, but here are just some simple classifications for triangles. Hopefully you've seen all of these words before, but get this vocabulary down as best you can. An equiangular triangle has all equal angles, or all the angles have equal measures. They're all 60 degrees. An acute triangle, all of the angles are less than 90 degrees. A right triangle has one right angle, and then the other two angles are obviously acute. An obtuse triangle has one obtuse angle. The other two are obviously acute. And so these are classifying based on angles. Equiangular, all the angles are congruent. Acute, right, obtuse, all right? Deals with the angles. Then these classifications are going to be based on the sides of the triangles. There's an equilateral triangle where all the sides are congruent. By the way, an equilateral triangle is also equiangular. An isosceles triangle has two congruent sides. We're going to learn that isosceles triangles also have two congruent angles, but this is referring to the sides, is how we describe that. And then scalene triangles have no congruent sides and therefore no congruent angles as well. So we're going to be using this terminology as we talk about triangles over the next couple months. And so it's important that we just kind of have this readily available. All right. Hopefully that wasn't a waste of time. Hopefully that was review. But if I'm using that vocabulary, it can be helpful to just kind of know those things. All right, back to parallel lines though. If we have a line and we have a point that is not on the line, then there exists a line that passes through that point that is parallel to the given line. Think of this as kind of the geometric understanding of what you did in Algebra 1 when you were given one line and then you were given a point and you were supposed to find the equation of the line that was parallel to this one but passes through that point. Same concept. There is one answer to that. There is one line that passes through that point that is parallel to this line. And so that is the theorem that we have here, Theorem 210. Basically, given line B and point P, then line A exists. We know that there is a line. There is only one line that exists such that A is parallel to B passing through point P. All right, so we use that theorem and that understanding along with the other theorems and postulates that we've already been given to show that the sum of the measures of the interior angles of a triangle is 180 degrees. And now this is maybe not a new concept to you. You probably already knew this information. If you didn't, then just make a little note saying I didn't know this already, and just be like, wow, like holy smokes. So the measures of these angles sum to equal 180 degrees. I'm not going to write out the formal proof of this, but through point C, there exists a line that is parallel to line AB here. I'm going to go ahead and draw that line such that it is parallel to line AB. If that's true, then I've got angle 1, angle 2, and angle 3 in this, so angle A, angle B, and angle C. But I'm going to label them angles 1, 2, and 3. And what we'll notice is that for these angles, I know that angle 1 and angle 4 are congruent. I know that angle 2 and angle 5 are congruent. Together, all three of these angles make 180 degrees. All right, so by substitution or by transitive property, however you want to make this extension in this logic, we can say that if 4, 3, and 5 make 180, then 1, 2, and 3 also make 180 degrees. Right? So that's kind of the informal proof, but I would invite you to try to write that as a two-column proof. That is not required for your notes points, but if you would like to do that, maybe there could be some kind of bonus for you, so think about doing that. So we use that, obviously, to do some basic types of equations to say, all right, well, the measure of angle 1 plus 85 plus 40 makes 180. We create equations, And then we solve those equations. You don't necessarily need me to do this, but I'm a nice guy, so I'll go ahead and create, or I'll keep working with that equation, solving this situation to find out that the measure of angle 1 is 55 degrees. All right? And so, so we create the equation based off of the situation. The sum of the measures of the angles is 180. And therefore, we combine our like terms. We subtract 125 from both sides, and we are able to find our solution, right? The measure of that angle. So the algebra hopefully isn't going to be too challenging. Use a calculator. I know that some of this addition, some of this subtraction is easy, but at the same time, it's silly to lose points by not using a calculator. So have that readily available while we do that work. All right, next, some other vocabulary. Related, but it kind of takes us to the next step. Exterior angles. All right, so inside of the triangle, these are interior angles. Outside of the triangle, if we were to extend out one of the sides, we would make an exterior angle. So I want to make sure that we understand that this whole thing is not an exterior angle, all right? That's going to be greater than 180 degrees. We haven't really conceptualized that yet. So what I want for you to understand is that at every vertex of every polygon, there are two exterior angles, all right? One if you extend out this side, there's an exterior angle. And then there's also one if you extend out this side, there's that angle. The neat thing about those is that those angles are congruent to each other. They're vertical angles. And so we only need to describe one at every vertex. We don't need to describe both at every vertex. All right? But an exterior angle is an angle formed by a side of the polygon and an extension of an adjacent side. So here is a side, and then this is an extension of an adjacent side. We've extended that one out. And that makes this angle 1 an exterior angle. Now the cool thing about angle 1 is that angle 1 and angle 2 are a linear pair. And so we know that angle 1 and angle 2 make 180. And we also know that the measure of angles 3 and 4 add with the measure of angle 2 inside the triangle to get 180. So we can make it an understanding, we can go through some geometric proof to show that the measure of angle 1 is equal to the sum of the measures of these other two angles in the triangle. All right, that's the next slide. Those angles 3 and 4 are referred to as the remote interior angles. So remote is one of those words that means far off or far away. You use a remote control to control your television. You can control the TV remotely. You can sit across the room and you can press the buttons. It used to be when I was a child that there was a knob, like an actual knob on the TV that you would turn and it would change the channel. Then they evolved to buttons that you would push on the TV to change the channel, and now we can push those buttons on the remote control and it will change the channel or up the volume, etc., etc. And so remote interior angles are the angles that are far away. So these are the remote interior angles from the perspective of angle 1. If I have a different angle out here, if I have angle 5, for example, then angle 5 is exterior. Angle 3 is the adjacent interior. Together those make 180. But from the perspective of angle 5, these two, angles 2 and 4, are now the remote interior angles. All right? So again, the vocabulary, it's great to understand that, but it's great to be able to apply that based on whatever perspective we are working from. So make sure that you understand exterior angle and then remote interior angle from the perspective of that exterior angle. All right? And I've already kind of spoiled it to say that in the triangle exterior angle theorem, the measures of each the measure of each exterior angle is equal to the sum of the remote interior angles from that exterior angle's perspective. All right, we subtract the measure of angle 2 from both sides, use some substitution or transitive POE, and we'll find out that the measure of angle 1 is equal to the measure of angle 3 and 4 added together. All right, so this is theorem 212, the remote exterior angle theorem. Now, these algebraic theorems are awesome because that means we get to create equations and solve for the value of the unknown quantity. So in these two pictures, draw those on your paper with all the figures. That's just an expectation that you have those figures in your notes. But we'll have the measure of angle 1 is equal to the sum of the remote interior angles. And so we're able to create that equation. And in this case, everything's on one side, so all I have to do is add those two things together to find out that the measure of angle 1 is 140 degrees. Now, in this case, This one's a little bit different. The exterior angle is equal to the sum of the remote interior angles. From this perspective, these are the remote interior angles, not this one, all right? This is the adjacent interior. These are the two remote interior angles. So 80 is equal to the measure of angle 2 plus 34. So I'm going to subtract 34 from both sides to find out that the measure of angle 2 is 46. All right? We create the equation. We solve the equation. Folks, that's really it today. Just wanted to do those couple examples. Wanted to make sure that we were able to solve exercises, solve problems using the measures of interior and exterior angles in triangles. Enjoy.